We're going to talk about intelligence, information, and design. 3 keys to the origin of life. And we're going to do something what might seem a little odd at first. We're going to set our Bibles aside for a moment. We'll come back to it later to tie it together. But we're going to pretend, kind of, that we don't have the Bible. We're just floating around out here looking at the world around us and trying to figure out why it's here, how it got here, that kind of a thing. We want to kind of feign neutrality for a minute and ask this question. Is life on Earth the product of blind, purposeless natural processes? Or is it the product of an intelligent being? How, and along with that, how might we be able to tell between the two? How might we be able to reach a decision about that? So, but to answer that question, the product of an intelligent being, we need to know what we mean by intelligence. Intelligence is one of those words that has about 48 different definitions in different contexts. And so it's important to understand what we mean by intelligence here. This little video, I've got 3 short videos. They have a little bit of audio, but the audio is not important at all. Come on in. The audio on these is, you're not going to be able to hear very well, but it's not important what the audio is. Just watch the video and you'll get the point. But this video will demonstrate what we mean by intelligence, and we'll talk about it after it plays. Whoops. There we go.
Oh, he's so cute.
It's just amazing.
If you just jump in the water.
I didn't want to get in the water. See when they're smart?
That's pretty cool, huh? So what was going on there? And how's that? And why does that demonstrate intelligence?
Well, first he didn't want to get in the water, and so he's trying to figure out a way to get the ball without getting in the water.
Very, very good. So the dog has really 2 objectives. That's the important part, is that he has an objective at all. He has 2 of them. One is to get the ball, and the other is to stay dry as much as possible, apparently. But notice those objectives are at loggerheads because the ball is in the water. So he's got to figure out how to make this happen. And so this is a manifestation of intelligence. There are goals, and there are end points in mind. He's looking forward to something that he wants to accomplish, maybe multiple things. Maybe these things are competing, and there's got to be some balance achieved or something. Sometimes I have trouble getting it to the next frame. Yeah. So intelligence recognizes a goal or an objective, and then intelligence makes decisions oriented toward realizing those goals. Maximizing maximizing all intentions. He wants the ball, so he's going to get the ball, but he doesn't want to get wet, so he's going to minimize the stuff that's bad, maximize the stuff that's good. He's going to try to bring stuff together in his environment in the video to accomplish those goals. That's intelligence, and we do that all the time, just without thinking about it, oddly enough. But so that's what we mean by intelligence. Who's ever heard of Rube Goldberg? Yeah, Rube Goldberg. So Rube Goldberg was a cartoonist and an inventor, an engineer in the 1940s, 1950s. Really known best for cartoons that he drew depicting wildly complicated contraptions that accomplished very mundane and silly little tasks. So here's an example of a Rube Goldberg cartoon. It's an alarm clock. If you didn't know, that's an alarm clock. And so you got the guy sleeping, and the early bird, gets the worm here in the window, and he pulls on the worm, and that pulls a string that pulls the trigger on the pistol, and the pistol fires a bullet that pops a balloon, and the balloon is holding up a brick, and the brick falls and squishes a atomizer that squirts perfume at a sponge, and the sponge gets heavy, and it falls down, and it lifts this board, which lets this cannonball drop onto the guy's face. And when the cannonball drops onto the guy's face, it pulls a cork out of a bottle of ice water to make sure that he wakes up.
That's like torture.
Good morning.
I prefer the traditional alarm clock myself. But this is the idea. So this is the idea of a Rube Goldberg machine, and if you want to waste several hours on any given day, just plug Rube Goldberg machine into a YouTube search, and you'll be amazed. And it's because this is like becomes an engineering project in colleges or high school physics. So it's a great exercise, and but sometimes you find here's a eighth grader named Jordan who's built a little Rube Goldberg machine. So we're going to watch how this works, and this is not long at all. There is audio here. You won't hear it very well, but it doesn't matter. Just watch the video. We'll see what happens. So he's going to try to crush a grape. That's the objective.
Oh gosh. Gets enough velocity.
So there it is. That's a pretty simple one, but there are some I've seen, on YouTube that just blow your mind. They travel through rooms of houses, and it's very creative and very fun, and maybe in a sense a waste of time, but I don't know. It just depends on why you're doing it, I guess. But so what you see here is that he has an objective. Granted, it would be easier just to smash the grape with your fist, but he has an objective, which is to crush a grape, and he's arranged some parts from his environment, made decisions to orchestrate these things, and it takes a kind of foresight, certainly not exhaustive foreknowledge like what we would attribute to God, but a foreknowledge of sorts, because he's imagining what's going to happen when this happens, and so forth. And he's making decisions along the way to achieve the final objective, but also to achieve the little sub-objectives that go before it, right? So the Rube Goldberg machine has an end goal or an objective. And it's typically a chain reaction, a chain of events, a cascade of events, each of which has its own objective. And if any one of those little sub-components fails, you don't get to the end objective, do you? Because the whole thing breaks down and it doesn't work. So these are characteristics of Rube Goldberg machine, and it's obviously very consistent with what we see with what we talked about with what intelligence is. You have to do all that. It requires intelligence to put these things together. Any machine. Rube Goldberg machines are funny and entertaining, but you know, this machine here is no different. It's just a lot more elegant. Anyway, so again, so we're faced with this question, kind of feigning neutrality. Is life on Earth the product of blind, purposeless natural processes, or is it the product of an intelligent being? How could we decide? Well, I have an idea, maybe. See what you think. If we found things in living organisms which could be compared to Rube Goldberg machines, if we found things like that, machines and gizmos and widgets and systems that were cascades of events where if one stage broke, the rest of it wouldn't work, this kind of thing. That seems like it would suggest, given what we've seen so far, that life was the product of an intelligence. Does that make sense? So, here's a short video that shows kind of some 3D visualizations, animated visualizations of some of the stuff that's going on in the cells of your body right now. That's DNA replication.
I understand that movement, it's like diaphragms individually. This is awesome. Here's the DNA strand.
So there's a lot of nanotechnology in there. There's a lot of little gizmos that read, that uncoil you. So the DNA replication, you had a machine that was a complex of proteins that are acting to strip apart the two strands of DNA, and then other machines next to it that were copying the DNA. One side had to copy it in short sections because it has to go backwards, but it looks like a machine. It looks like something you'd see in a factory. Ka-chunk, 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 ka-chunk. You know, really phenomenal. And so those are impressive. But then you get to things like this. You don't need to worry about understanding this diagram, but this represents the blood clotting cascade. And it's just a functional diagram of what happens when you cut your finger. What has to happen when you cut your finger, what should happen. whatever. And what you see is that blood clotting cascade is a cascade of chemical events in your blood at the location of an injury. And they have an end goal in mind: to clot the blood, to stop the loss of blood at the site of the injury, and to help, promote healing the injury. It has this all these these chain of events that have to happen in sequence, and if any one of them fail, the whole thing doesn't work, and you have blood that doesn't clot. Or maybe if something else is wrong, maybe the blood just all clots, which wouldn't be very good either if all your blood just suddenly up and clotted, And this is, it looks pretty complex. It's got a lot of stuff going on. Now here's a diagram that kind of describes Jordan's 8th grade Rube Goldberg machine project that we saw with the crushed grape. That's pretty simple compared to that. But the question is, if I can see that something very simple like this requires intelligence to put it together, why would I think that this, which is even more complex, could happen by some blind, purposeless natural process? That doesn't make much sense, does it? So we do find things that are comparable to kind of Rube Goldberg machines, and I don't mean, sometimes Rube Goldberg has kind of a pejorative Mickey Mouse, this doesn't really work right kind of feeling, and that's not what I'm after. I'm after the complexity, the cascade, the events, and that sort of thing associated with a Rube Goldberg machine. So we do see these kinds of things in biology that ought to tell us something, I think. And should give us a good reason to think that life is the product of intelligence rather than blind, purposeless natural processes. There's another thing we should talk about, though. Something else that we find in biology that's interesting, and that is information. And information, like intelligence, it's another one of these words that has a lot of different meanings. So what do we mean by information? There was a guy named Claude Shannon back, I think, in the 50s and 60s. Was an information theorist. He worked for Bell Telephone, and his job was to figure out how to move a message from point A to point B in the most efficient manner. And so he did a lot of work in this area with dealing with information, and he described information as the reduction of uncertainty. And if that seems odd to you right now, I think I have a way of making it more clear. Suppose there's a football game tomorrow. Now, I didn't misspell anything up there. This is my attempt at neutrality. Okay, so if I tell you there's a football game tomorrow between the Bucks and the Devers, and I tell you that if the Bucks don't win tomorrow's game, the Devers will. Have I reduced your uncertainty at all? Kind of, don't you already know that? Doesn't really tell you much, does it? It doesn't inform you. You are just as uncertain about the outcome of the game as you were before. But as if I could know, what if I said the Bucks will defeat the Devers 36-28? Now I've reduced your uncertainty. Again, assuming I could know. Or at least I've given you something that you could test. And you could watch the game and see if that's the way it turns out. So this is information. That, not so much. That's not very helpful. There really are two different kinds of information. We'll get to that in a minute. But here's another example from our nation's history. The Midnight Ride of Paul Revere. We're not going to read the whole poem, don't worry, but this is a very good example of information in action and demonstrates where information comes from. He said to his friend, "If the British march by land or sea from the town tonight, hang a lantern aloft in the belfry arch of the North Church Tower as a signal light. One if by land and two if by sea, and I on the opposite shore will be, ready to ride and spread the alarm through every Middlesex village and farm, for the country folk to be up and to arm." So Paul Revere and his friend, whose name was Ebenezer Dorr, they hatched this little scheme. They need to reduce the uncertainty of the people in the town nearby as to where the British Army was coming from, by land or by sea. And they needed, they didn't have cell phones. So Paul Revere sent Ebenezer Dorr around the harbor to the North Church Tower. And he said, "Look, keep a lookout. When you see them, tell me if they're coming by land or by sea. And this is how I want you to tell me. One lantern if by land and two if by sea." So in an instant, just with this simple binary code, from across the harbor, Paul Revere's uncertainty can be reduced, right? And then he can go and reduce the uncertainty of the people in the town, and then we know what happened next. This is information. It informed people, it reduced their uncertainty, and where did this information arise? Did it arise by some blind, purposeless, natural process, or did it arise in a mind? Kind of an interesting thing to think about. Most of us are familiar with this little artifact. What if I was to tell you that this was the product of blind, purposeless, natural processes? Be a tough sell? Seems like it. And it wouldn't even have to be in the town of Bend, would it? I mean, you might wonder why they put this in the town of, Richmond or whatever. That might be a good question, but you'd still have no problem knowing that this was not a product of blind, purposeless, natural processes. You would know that an intelligent landscape designer was behind this, okay? And does it reduce uncertainty? Well, maybe not to us, because we already know where we live. But to the guy that's 2 o'clock in the morning or whatever, and he's driving to Bend, and he saw the sign a few miles back that said 4 miles. When he gets to here, he goes, "Oh, finally, I'm here." Well, that's reducing his uncertainty. Now he knows where he's at. This carries information, and we know that information comes from a mind, from an intelligence. I said there are two different kinds of information. And the easy way to, well, it's not an easy way, because these are kind of weird ideas, but it's kind of fun way to differentiate between the two. Suppose I tell you, meet me tomorrow at noon at Starbucks, and I'll give you $1 million. Don't worry, I won't be there. So nobody show up there tomorrow. I don't carry that kind of cash. But meet me tomorrow at noon, Starbucks, I'll give you $1 million. Does that reduce your uncertainty about where to be and when tomorrow? Assuming it was genuine. Of course, it would reduce my uncertainty. I'll just be honest. I would be there. How about that? Does that reduce your uncertainty? No, it's complete nonsense. But because there's these two different categories of information, if I was careful about how I defined it, I could actually tell you, and be honest, that this has the same information content as that. Does that seem strange to anybody? So this is one of those things where both are true in a sense, but they're different senses, so it's not a contradiction. This is both kinds of information actually, and this is only one kind. So let me get to that. Both of those sentences, 15 words, 59 letters, 11 spaces, 1 apostrophe, and something like, I think it was 584 bits of data, okay? So in that sense, they're equal. They have equal information content. If you typed it up in a text file and saved it and then measured the amount of space that takes up on your hard drive or whatever, it'd be the same, okay? But see, there you're ignoring the content, aren't you? The content in that sense doesn't matter, like this. The content doesn't matter. But clearly there's something very different between these two sentences, isn't there? One communicates a message and the other one doesn't communicate anything. Both are equally improbable sequences of letters. There's nothing less probable about this one than this one. They're both equally improbable. But this one carries a function. It means something. And that is a particular kind of information that we want to zoom in on, called complex specified information. Meet me tomorrow at noon at 7-Eleven or whatever I said, and I'll give you $1 million. That's complex specified information, but the gibberish is merely complex information. It's not specified, it doesn't produce a function. So complex information is very low probability, but complex specified information adds to very low probability the fact that it matches an independently given pattern or produces a function. Here's a great way to illustrate it. Mount Rushmore, before and after. Okay? We would have no trouble attributing the left-hand picture to blind, purposeless natural processes, would we? But both cliff faces, both rock formations are just as improbable in a mathematical sense. They're both unique and they're both very highly improbable. But the one on the left doesn't match any independently given pattern. The one on the right has faces on it we recognize. And that tells us which one of these was the product of intelligence. The one on the right. It's an improbable arrangement, and it matches an independently given pattern. So this is complex specified information, and that is what we find in DNA. In the DNA that codes for the proteins that basically run your body, that drive life. All of biology is conducted by means of this DNA molecule and the programming that's in it. So here's a question. I wonder if we're looking for complex specified information, can blind, purposeless natural processes create that? Well, I don't think it could, but let's just try it. Let's just give it a whirl. I'm going to pass this around. We'll just do the first 2 rows here because we don't need to go forever. But I'd like you, sir, to just pull out one letter and pass it down. And you'll circulate around. And we're going to write down what we get. All right, so you have T. O. Well, that's looking pretty good. Could mean table of contents. I don't know. Okay, and
H.
yeah, and then you can just dump those back in and recirculate it. I'm sorry, what was it?
H.
H. Okay. H.
D.
J.
P.
Okay. Somebody want to read that for me?
No.
What language is that?
Nothing.
It's gibberish. Now, well, maybe we could just run the experiment longer. Would it get better or worse?
Worse.
It's just going to get worse, isn't it? And this is not very many letters. I mean, you know, this is a pretty low level kind of experiment. If we can't get it to work at this scale, how's it going to work at a big scale? You know, grab that back from you. Thank you very much. All right, so we don't think we have pretty good. That's a pretty good reason to think that blind, purposeless natural processes can't pull this off. Well, let's go a little further. So back to complex specified information. Here's some examples of where you might find complex specified information. A cookbook. If you want to have your uncertainty reduced as to how to make chocolate chip cookies, cookbook, that's a good place to start. So it contains instructions, right? Instructions are complex specified information. If you want to build a house, kind of hope that you would reduce your uncertainty about where to put the doors and the windows by having blueprints handy. And then we have the disk drive. So what is a disk drive store?
Usually
Information.
The operating instructions for the computer.
Ooh, very good, very good. I mean, it's all information, but I am kind of after the software idea specifically, and that's what he's talking about. Software instructions that operate the computer. Instructions, 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 right? They're maybe for different purposes, but that's okay, right? Software, that's interesting. So software is an example of complex specified information. Again, we're considering our neutral question here. Blind, purposeless natural processes or an intelligent cause? How could we decide? We already have one reason. We're just going to see if we can stumble on another one. If we found complex specified information in living organisms, it seems like we'd have a second reason to think that life was the product of intelligence as opposed to blind, purposeless natural processes. Professor of natural philosophy in Germany, Bernd Olaf Kuppers, says the problem of the origin of life is basically equivalent to the problem of the origin of biological information. You figure out where the information in DNA comes from, you figure out the origin of life. It's the same question. That's the point. Now, think about the relationship between software and complex specified information. Apple computer. Do they employ blind, purposeless natural processes to write software?
No.
No, that's Microsoft, right?
Oh, sorry.
No, they employ very intelligent software engineers. We hope, anyway. So I wonder if we could find something akin to software in living organisms. And if we could, what would that tell us about this question? And wouldn't it be neat? You know, we can go to Institute for Creation Research and Answers in Genesis and all reasons to believe and all that, and that's good. But wouldn't it be cool if we had atheists telling us DNA was software? Here's Francis Crick. He was the co-discoverer. Discovery is not really the right way to say it, but he and James Watson were the first to describe in 1953 the DNA molecule, and they from there began to start slowly figuring out what the DNA molecule did, what its function was. And in 1958, Francis Crick came up with this idea of the sequence hypothesis, which suggested that the nucleotide bases along the spine of the DNA molecule function as alphabetic characters in a written language. That's complex specified information, written language, or digital characters in a machine code. Machine code is what? That's software. Richard Dawkins, who can think of a more prominent atheist? I think this is from his book, The Selfish Gene. The machine code of the genes, that's DNA, is uncannily computer-like. J. Craig Venter, who's instrumental in the Human Genome Project a few years ago. He says that cells are software-driven machines. That's interesting. And he's not a theist, by the way. Software-driven machines, and that software is DNA. And then he says this: the secret of life is writing software. Boy, you can't get much closer than that, can you? The secret of life is writing software. What does writing software require? Intelligence, does it not? Bill Gates. I know, I just trashed Microsoft, so now I'm using Microsoft. DNA is like a software program, only far more complex than anything we've been able to write. So, again, do blind, purposeless natural processes write software, or do beings with intelligence write software? Well, we know the answer to that. And what's interesting to me is to see how history progresses and pushes us towards these conclusions progressively. Well, we'll get to that in a minute. But there seems to be this systematic peeling away of the I don't know, blinders. You want to say? I don't know. We'll get to that in a second. But so. The funny thing is that when you pay close attention to some guys like Dawkins, and here's Carl Sagan. Some of us have heard of Carl Sagan, perhaps. He was part of the, he's famous for this, saying the universe is all there is, all there ever has been, and all there ever will be. And he said that we're just made of star stuff, whatever that means. He's a naturalist. He thinks that this is all there is, and he was an astronomer, so he didn't really traffic in biology kind of stuff, but he bought the broad scheme of evolution, of course, and would deny the existence of some intelligent, creator. But if you pay attention to these guys enough, you'll find them admitting things they shouldn't admit from their perspective. And I think that's really funny when that happens. And I'm going to show you an example. You ever seen this movie? Who's seen this movie? So it was a novel that Carl Sagan wrote, and it became a movie. And it was an interesting movie. It kind of goes in some weird directions eventually, but it's about the search for extraterrestrial intelligence. It's the SETI project. This is where scientists listen through radio telescopes to radio noise from deep space, in hopes that they will recognize something odd about some radio signal and figure out that it's from an intelligent source. Whoops. What did they just admit?
Intelligent source.
They just admitted actually a couple of things, really. But so here's the story goes. Just the important part of the story is that they're listening to this equipment, and eventually they get this series of pulses in the radio signal that stand out, and they keep watching them, recording them, and at some point they realize that these pulses add up to the first 100 prime numbers. And when they have that realization, that light bulb moment, they throw a huge party because they just realized that they've received a signal from an intelligent being. Now, that admits two things that Carl Sagan should not have wanted to admit. But, he's not paying attention to that. He's writing a novel. It admits, first of all, that intelligence can be detected reliably through scientific means. And a lot of people will tell you that theories like intelligent design aren't science because they're not testable. Oh, really? I just about bet you they supported SETI when SETI was still operating. So, you know, that's not very consistent. But they're also admitting that they realize information always arises from an intelligence. You get a string of the first 100 prime numbers, that is not complex information, that's complex specified information. It matches a pattern. Okay, and so, and in the movie, they end up, that turns out to be nothing more than a sort of a handshake, and they go on to sort of download, you know, sort of blueprints for this intergalactic transportation thing, and it kind of goes weird from there, but you get the idea. They really kind of gave away the store with this story, didn't they? They really left themselves exposed. They're admitting the very things they want to deny when it comes to what we find in biology. We find software, we find complex specified information. If the digital code in DNA was like, you know, somehow retranslated and broadcast through so that the digital, so those radio telescopes could pick it up, they'd go, woohoo, we found intelligent, you know. It's the same thing. It's the same idea. And Carl Sagan clearly understood the basic principle that information is the product of intelligence. And he also understood that it could be detected. So what do we do with this? What does this mean to us in our conversations with people, in our own personal, you know, just soliloquies that we have in our mind? Well, one thing it means is that belief in God, theistic belief, is not a leap of faith. It is not comparable, as some have said, to belief in, say, Santa Claus, okay, or the flying spaghetti monster, or whatever ridiculous, you know. There's actually reasons that point us in this direction, and it's not just, oh, I just believe. There are reasons to back that up. And we should know those. And we should present them in a reasonable, respectful manner and all of that. And I like what Dr. Hazen was just saying. When you have this knowledge, you don't have to spill it at every opportunity. But ask questions as they ask questions of you. Ask questions, get information from them about what they think some of these things mean. Ask probing questions about other places where you might find information and see what they think about where those sources came from. Don't just drill with the, don't just spew the knowledge, you know what I mean? We don't need to do that, and sometimes it might be counterproductive. So belief in God is not a blind leap of faith that's contrary to evidence. It actually is consistent with evidence. There are good reasons to believe that God exists. Two reasons we've seen. One, a machine requires a designer or an engineer. We have machines in here on a nanoscale, sub-nano, you might even say. And a software program requires a software programmer. There's nothing unreasonable about those ideas at all. This is very straightforward stuff. Now here's what's interesting. So we can take our Bibles out again, so to speak. Because this verse, and I think Psalm 19 also would fall into this category. Well, let me read it. see if you get it. See if I get anything wrong. For since the creation of the world, his invisible attributes are clearly seen, being understood by reading the Bible. Oh, wait a minute. Oh no, I got that. That was wrong, wasn't it? No, they're clearly seen and being understood by the things that are made. I'm not telling you to disregard your Bible. We need the Bible for a lot of things. But what Paul is saying here is that that's not where the evidence of God is, of God's existence. That's not found in the Bible. The Bible speaks about God as though he's a giver, essentially. In the beginning, God created. It doesn't try to really persuade us within the pages of that very thing. Rather, there seems to be this broader design that says, sort of this general revelation, we've heard this term, right, of creation pointing us, sort of rattling our cage, saying, hey, you guys are not the end game here. There's something bigger going on. It's general revelation seems to be pointing us in that direction. And then we have the Bible, when we have a positive response to that general revelation. Then we see the Bible as special revelation, and we have more specific information. Pardon the reference. So the Bible is very, very important. But God reveals himself, Psalm 19 says, the heavens declare the glory of God. Well, the Bible does too. But do you see the point I'm making? There seems to be a kind of a hierarchy here that God has presented. And I guess part of what I'm saying is we should be aware of that, and then we should use it. We should use the knowledge when we can to kind of turn up the volume on the evidence that we have available to us and allow people to, to demolish the strongholds. It's a good way to put it. To tear down these facades that have been erected against this knowledge so that people can see for themselves. So that's the end of it, and I'm happy to take any questions or comments.